Hi everyone. Today we'll be working on question 1229 on LeetCode called Meeting Scheduler. So we're given availability slots of slots 1 and slots 2 of 2 people and meeting duration, call duration. And we want to turn the earliest time slot that works for both of them and is of the duration. So in this case, if you take a look at these two, you can pause the video for a second and understand why the answer is 60, 68. Because starting between this interval and this interval, they intersect. And since 120 is a lot greater than 70, and since 70 is 10 greater than 8, we can fit the interval between 60 and 68. So how do we do this? Well, this question is actually very similar to interval list intersections. We first have to find an intersection, and as long as the intersection is greater than our duration that's given, then we can return it. So first, because I do not think it guarantees that the two lists are sorted, let's sort them first. So slots 1 sort. So we want to turn it in increasing starting time order because we want to first compare their starting times. And same thing with the second one. Then we have 2 pointers starting at the beginning of each of the new arrays. And iterate. So while Q1 is Q1, Q2 is To find the intersection, we always find the max between the start times and the min between the end times. If you want a clear explanation on this, please take a look at interval list intersections, but to make it really quick, let's say these two lines represent my 2 times that I'm comparing. If I want to find the intersection here, I'm finding the max between the start times and the min between the end times. So I hope that makes sense. Cool. So we can say the start time equals max 1 p1 0 that's 2 p2 0. The end time then be the minimum p1 1 for the end times. And just like before, we want to check whether the start time is greater than our end time because that's the only way it's going to be a valid intersection. So if start is greater than or equal to end, and minus start is greater than or equal to duration, then we can return the start time plus the start plus duration. Let me explain this really quick. Because we want our current or our end results to be the earliest time of duration given, then we want to basically make sure that the end time minus the start time will give us a positive number, which is what this determines. Oh, sorry. So this is actually a starting equation. And that the intersection given is of length duration. If it is, then we don't return start to end. We only want it up to that current duration. So it's whatever start time is given plus whatever the start time is given plus the current duration. Then to determine which pointer moves next, we can say if slots p1 1 slots 2 p2 1 should be slots 1. Then we move our p2 plus p1. What happens here is we check the end times. Whichever one has a shorter end time gets moved because that guarantees that we might have a a more guaranteed intersection for the next iteration. Otherwise, if we can't find a good intersection of length duration, then we return an empty array, as seen here. Let's see if this works. Works just fine, and works just fine. If you want to make this a little less redundant, because I just noticed something, if n minus start is greater than or equal to duration, then you don't even need this first statement here, because this first statement basically means that n minus start must be positive, but this already guarantees it's positive as long as duration is greater than or equal to 0, which it says over here in the constraints, which I just noticed. So we don't even need this line. Cool, let's talk about runtime real quick. Runtime for all of this. Since we are sorting the two, this is n log n and m log m, where n and m are the lengths of slots 1 and slots 2 respectively. Iterating here is O of n plus m, where we just go through both of the slots. So since n log n is asymptotically higher than just n, the entire runtime is then O of n log n plus m log m, where n and m are the lengths of slots 1 and slots 2 respectively. Cool. So once again, this question shares a lot of similarities with interval list intersections. I would do that one first before trying this one because they're almost exactly the same question. So with that, I'll put a link to the question as well as my GitHub down below, and I'll see you guys next time.